Welcome to the C++ programming from problem analysis to program design 5th edition. Let's go to the second topics, the language of a computer. Electrical signals are used inside the computer to process information. Most of the signals are propagated from the wavelength, amplitude, and so many frequencies. There are two types of electrical signals, like analog signal and digital signals. Analog signals are known as a continuous wave, forms used to represent such things as a sound. For example, most of the time the sound is used as the quality of sound known as a timbre. A timbre we have to see, and it can detect as the sounds like earthquake, tsunami, and so many sounds like that. It also includes the waves like sinusoidal waves, in addition to the wavelength, amplitude, and frequency like the oscillatory simple harmonic motion. Audio tapes, for example, store data in analog signals. Digital signals represent information with a sequence of zeros and ones. A zero represents a low voltage, or it represents false, and one represents a high voltage. It represents true. Digital signals are more reliable carriers of information than analog signals, and can be copied from one device to another with exact precision. You might have noticed that when you make a copy of an audio tape, the sound quality of the copy is not as good as the original tape. On the other hand, when you copy a CD, the copy is as good as the original. Computers use digital signals. Because digital signals are processed inside a computer, the language of a computer called machine language is a sequence of zeros and ones. The digit 0 or 1 is called a binary digit or bit. Sometimes a sequence of zeros and ones is referred to as a binary code or a binary number. A sequence of 8 bits is called a byte. Moreover, 2 to the power of 10 bytes, 1024 bytes is called a kilobyte. Now let us see here, which is given on the table. Let us see the table here. The language of the computer. It's given here. Byte. It includes 8 bytes. The kilobyte. It includes 1024 bytes. And megabyte. 1,048,576 bytes. And gigabyte. Also 1,073,741,824 bytes. And terabyte. It includes 1,511,627,776 bytes. And the petabyte, it includes 1,125,899,906,842,624 bytes. And exabyte, it includes 1,052,606,846,946,976 bytes. And zettabyte, it includes 1,60,180,617,411,303,303,424 bytes. Every letter, number, or special symbol, such as star or a braces on your keyboard is encoded as a sequence of bits, each having a unique representation. The most commonly used encoding scheme on personal computers is the 7-bit American Standard Code for Information Interchange, or ASCII. The ASCII data set consists of 128 characters numbered 0 through 127. Inside the computer, every character is represented as a sequence of 8 bits, that is, as a byte. Now, the 8-bit binary representation of 65 is 01000001. When you're happy about that, you can create a lot of, and ASCII is a 7-bit code. Therefore, to represent each ASCII character inside the computer, you must convert the 7-bit binary representation of an ASCII character to an 8-bit binary representation. There are other encoding schemes such as EBCDIC, used by IBM or International Business Machine, and Unicode, which is more recent development. EBCDIC consists of 256 characters. Unicode consists of 65,536 characters. To store a character belonging to Unicode, you need 2 bytes. So it will continue until we end this unit.